Welcome back, guys. Today we're going to talk about not creating matrices, but how we then actually retrieve elements from a matrix. So first of all, let's create a test matrix. So retrieving elements from a matrix, indexing and slicing methods. Okay, so let's create a matrix. Let's call it mat, and we'll do a matrix of 1 to 100. That's just literally the number 1 up to 100. We're going to set it by row, and we're going to make it equal to true. I'm going to specify the number of rows, and we'll say 5. So I'm going to run that line. So I'm going to clear my history first. I'm going to run that line. Oh, let's just do 50 actually. If you think about it, we'd need 10 rows, wouldn't we? What's that? Oh, okay. I've not wrapped it in parentheses. Schoolboy error. So number of rows equals 5, and let's make it actually 1 to 100. Okay. So let's print out what that looks like into the console window. Mat, and run it. Okay. It's a bit of a bigger matrix than we've created previously. I'm actually going to shrink it down a little actually, because there's quite a lot of elements there. Let's do 1 to 50 and let's rerun that. Yes, it makes it a bit easier to visualise. So row 1 has got 1 up to 10, row 2 has got 11 up to 20, etc, etc, etc. So if I wanted to grab or index the first row and return it all, I'd use matrix, which is the name of that I've just created in my matrix, the placeholder for it. If you can remember, in the vector element we opened square brackets, and with matrices, because they're two-dimensional, there's a row and a column, you need to say, if I wanted to grab the first row, I'd put 1 for the first row, because it goes row and column. But if I don't want to grab any columns, I still need to use a comma and leave after the comma blank. So I'm saying, don't give me the column, just give me the first row. So let's see what that does. Okay. Let's see what it did if I left out that. It would run an error. It just give me the first element, essentially, not the first row. So that would give me the second element, etc, etc, etc. But that's not really what we want. We want to say, give me the first row of data. So I need that comma. Okay? Conversely, if I wanted to grab the first, or get the first column, I'd reverse that order. So I'd say matrix, and I'd do a comma first, and then I'd say 1. See the difference? 1 there, 1 there. 1 on the left, 1 on the right. So I run that, and then it gives me, if we go back to up to our matrix, 1 down to 41. If I grab the second column, it'd be 2 down to 42. But we're going to keep it on the first column for now. Say I want to get the first 4 rows, or the first 5, let's say 5 rows. So I go back up to my matrix just to familiarise myself. So 1, 2, 3, 4, 5. The first 5 rows probably not. Let's get the first 2, because that is all that's there. So retrieve the first 3 rows. So that's very much similar. What we're going to do now is use our notation of 1, 2, 3. So that's a slice of 1 to 3, and then remember we have to put the comma there because we're after rows, and it gives us the first 3 rows. Let's combine these functions together now. So let's say retrieve the first 3 rows as we did before, and then give me the first 4 columns. And the first 4 columns. So this is what we do. We'd follow the same convention of previously, and then we'd go 1 to 4. So that should give me a kind of cut off of this. So there, it should cut it off at 4. Yep, so that makes sense. So essentially we're selecting by row and column then, but we're using the slicer notation, which is the colon. One final example is I could grab, say, the centre of it, so, or 47, yeah. So let's say give me, oops, got my caps lock on. So let's do 1 to 4 this time, so 1 to 4 rows, and that will give me 5 to 7 in a column sequence, and that will give me a subset of that. So it will give me, if we go back up here, it should give me 5, yeah, 5 down to 35, go back up, 5 down to 35, and then it does the same, so it's just giving me another subset of that matrix. Okay, we're going to extend this now. So we've done vector indexing and slicing. We're going to also add vector arithmetic. So again, we'll use the mats we've already created. So 1 to 50 with the number of rows of 50. So we're going to use that. So if we just return that again, let's just clear the console at this stage and move down on our script file a little. Okay, we're going to use the mats function again, and just return that for now. So you don't actually have to use the term print, it will return it without using print, but I use it most of the time to get as convention. So if I wanted to perform, say, multiplication on this, I could say give me 4 times whatever the number is in mat, and that's how I do it. So that would give me 1 times 4 is 4, 2 times 4 is 8, etc, etc, etc. Again, if I wanted to divide the matrix, I could go 1, take away the matrix. Okay, gives me 1 down to, you know, whatever value. And then I could do it the other way around. I could do mat divided by 2. Yep. I could say, let's raise the matrix to a power of something, probably 2, power of 2. So we do that by mats to the caret. Let's use a caret symbol, which means power of 2. That gives everything to the power of 2. You can even use comparison operators on the matrix, so I can say comparison operators on matrices. I can use give me all those values, or give me return if it's true or false, whether all those values are greater than some number that I'll specify. Let's say the matrix is greater than, let's say, go back to the original matrix, matrix greater than 35, say. See what that does. Okay, so basically it goes back to the, let me just print the matrix out before that, and we'll do those together. So that's the original matrix now without the arithmetic applied. So let's go back up and say all those that aren't should show as false when we start to get greater than 35, which is 36, so it should be all these rows here. You should see those have now been replaced with trues. You could also do matrix arithmetic if you had essentially 2 matrices that you wanted to add, divide, or multiply together. For this example, we use mat twice, but you could have it like as mat 1 times by mat 2, something like that. So instead we'll go mats plus mats, which will give you all the numbers added together by itself. 1 add 1 is 2, 2 add 2 is 4, 3 add 3 is 6, etc, etc. I could then do mat times mat as another example. I'm not going to go into all the operators again, but yeah, it just times it by itself. That's all there is to it now on this chapter. Again, subscribe to my YouTube channel, check out Hudson's Hacks, and I'll see you at the next video. In the next video we're going to look at categorical matrices. So with categorical matrices we use the factor operator. So I'll see you next time, guys. Hopefully finding these informative and you're following along. Please let me know if you want any of the example files, but I would actually advocate following along with the tutorials. Alright guys, catch you next time. Thank you.